Okay, this is week 7, group activity. This first one here, I'll write what is the equivalent decimal number. So I went ahead and rewrote it. So you can see what it looks like in scientific notation and place that E with a 10. Then I wrote the notation for scientific notation where A times 10 to the n. You can see that A is equal to 3.44, n is equal to negative 3. So since n is negative, shift the decimal point to make it smaller, n times. So I shifted 3 times. Okay, so that means I go 1, 2, 3, decimal point goes there, backfill zeros. 1, 2, 3. So my final answer is 0.00344 for my answer. And that's what they have there. That was number 1. Number 2, you can use the calculator here and add these numbers up and you should get 1.6. This next one here, you're dividing. Okay. They want here, their answer should be in scientific notation. Then they want it expressed as a whole number. So when I have this number here, I rewrote it. What I can do here is 7.1 divided by 8.9 times 10 to the 6 over 10 to the 3rd. Okay. So I can take 7.1 divided by 8.9. End up with 0.79. Okay. And they rounded approximately to 8. And so I have here 10 to the 6th divided by 10 to the 3rd. The 3 there. There's the 3. Times, and that gives me 10 to the 3rd here. So I divided 10 to the 6th divided by 10 to the 3rd, and it should give me 60 here. I divided. I got 0.79, that rounds up 0.8. And in this case here, 10 to the 6th divided by 10 to the 3rd gives me 10 to the 3rd. It's not in scientific notation, so I have to rewrite it. So I shift it over one place to make it 8 times 10 to the minus 1 times 10 to the third gives me 8 times 10 squared for my answer. And that's what they have there. And what would this be as a whole number? Well, I have 8 times squared, which is the same thing as 8 times 100 or 800. Okay, so this one here, I have 3.7 divided by 6.341. The least number significant digit, so that's one place over. Okay. Times 10 to the third divided by 10 to the minus 3. Okay, so I divide. I have what here? 3.7 divided by 6.341. Okay, when I do that, I end up with something like 5.8 and times 10 to the 6. It's a negative, so it belongs someplace else, belongs up top, makes that 10 to the 6th. So I have 0.58 times 10 to the 6th. And so rewrite that over 1. So I end up with 5.8 times 10 to the minus 1 times 10 to the 6th, which would be 5.8 times 10 to the 5th. That's my answer there. I have 5.8 times 10 to the 5th, 5.8 times 580. Awesome. That's my answer there. Okay. This one here. Number 3. Multiplying out, we end up with 4.1 times 6.5 times 10 to the 24 times 10 to the 14. Multiply 4.1 times 6.5. 4.1 times 6.5. And I end up with 266. Okay. 26.65. 26.65 times 10 to the 24th times 10 to the 14th. But when I put this in scientific notation, it's going to be what? Shifted over one place. I have 2.665 times 10 to the first. And to the 24th times 10 to the 14. So I have 2.655. There's my answer there. Write this in scientific notation. So I have here 0.000478. So I shift my decimal point so it comes to a number of A's between 1 and 10. So I go 1, 2, 3, 4. So 1, 2, 3, 4. A is equal to 4.78. And N is shifted in this direction here to my right. So my N is going to be a negative number, a negative 4. You have A times 10 to the N. You're going to have 4.78 times 10 to the negative 4. And that's your answer. Next one here. Okay, and this one they want us to convert it. Do what we did last time. Each time you convert this, you want meters to cancel out with all of these. So I'll do 3 of them. First 3 here. So I have here what? 41.56 meters, and I want meters to go away. And for this one, it's going to be similar setup for 41.56 meters, and I want meters to go away. With this third one here, I want to have same number converting to 50 meters, different one I'm converting it to 41.56 meters, and I want meters to go away. 1 meter, 1 meter, 1 meter. So the first one there is so we have kilometers there, kilocalorie. So in this case here, convert that to 1 meter and convert it to 1,000. Okay, so in this case here, I have here, it's going to be what? 1 meter is how much of a 1,000th of a kilometer. So I'm going to have 0.001 kilometer. So you can do that too. Or you can do this too. Let's see here. Let's see if we can do this. Let me pause. Make it easy. 1,000 meters is 1 kilometer. I have 41.56 over 1,000. The units, the meters cancel out, and I'm left with just kilometers. End up with 0.04156 kilometers. Next one there is millimeters. So I can rewrite this here for the next one. $1,000. 1 meter corresponds to 1,000 millimeters. So meters cancel out, and I multiply. So I have 41.56 times 1,000 millimeters. And that gives me 41,560 millimeters. Next one there is femtometers. Okay, so femto is down here. So in this case here, femto is 10 to the negative 15. What does that mean? Well, let's look at deci. Deci is 10 to the negative 1. So it would take 10 decimeters to make 1 meter. It'll take 100 centimeters to make 1 meter. It'll take 10 to the 15 femtometers to make 115. So this is 10 to the 15 of these small things here, smaller than a millimeter, 10 to the 15 of them to make 1 meter. So that's 10 to the 15. Okay, so 1 meter is 10 to the 15 femtometers. All right. And in this case here, we have a large number, and we want to put that in scientific notation. And we do that, we end up with 4 times 4.156 times 10 to the 16. So what's happening here? Let me go back. So we have this 4.56, which is going to be 4.156 times 10 to the first times 10 to the 15th, which just gives me 4.156 times 10 to the 16th, which is what they have there. And that's how you do those. You go ahead and complete those there. And the next one. Match the prefix with its value. Okay, to give you the prefix here, they want it in doing the same thing similar to what we did before. They give you the meters and they want you to convert it. We've done that before. Given meters here, convert it. So that's kilo, that's 1,000. So I would have okay. Similar to what we just did before. 2.0 25.51. And we have meters here. We want to get rid of meters and play in terms of kilometers. So we know that 1,000 meters is 1 kilometer. Multiply it out. Meters cancel out and they end up with 25.51 divided by 1,000. And the unit is kilometers. End up with 0.2551 kilometers, what we had before. So similar to what we were just doing before. Many of your numbers is decimal or whole numbers. So they abbreviated when they got really large. Otherwise, they put them in decimal form. And this one here, take it and rewrite it in scientific notation. So terawatts is going to be teras 10 to the 14. So I have 3.67 times 10 to the 14. Rewrite it in exponent in terms of multiple of 3. I can take this down to 10 to the 12, so I can rewrite it. 3.67 times 10 to the minus 10 squared times 10 to the 14 times 10 to the minus 2. So this will give me 3.67 times 10 squared to be 367. And 10 to 14 minus 2 is going to be 10 to the 12. And that's your answer there. Next one there, to give it to you in scientific notation. So I have 7.37 times 10 to the 7th, 10 to the negative 7. And I can go down to a negative 9, so I can rewrite that. 7.37 times 10 squared times 10 to the minus 7 times 10 to the 9th minus 2. Okay. And 7.3 times 10 squared will be 737 times 10 to the minus 9. That's a multiple of 3 there. And you continue on there. And I'll do a third one. Here I have 8.47 times 10 to the 8th. I can take that up 1. So times 10. So up 1. Go down 2. I'll take it down 2 and make this, that'll make this within 100, so I have 8.47 times 10 squared times 10 to the 8th times 10 to the minus 2. This gives me 847 times 10 to the 6. There, this way I have a number that's between here is between 1 and 1,000. Okay, and that's the answer there. And that's the answer there. So in this case here, you can take 367. I'll do this one. Nanobytes. Nanobytes. 10 to the minus 9 here. Alright. So nanobytes, you can see nanos there's to the minus 9, so after 737 times 10 to the minus 9. And for this one up here, and you would multiply that out and you get that number. Then you put this in scientific notations in that form. So tera is 10 to the 12. That number there, you put it in scientific notation. Looks like that. So that's what you end up doing there. And this one they want us to put it in engineering notation. So you can see there what it is in scientific notation. You can go ahead and put that in. Femtobytes, convert that into bytes. And you can see what they did there. And from the table. So in any case, we have in scientific notation here, I have 8.27 times 10 to the negative 13. And I want to take it to be a number multiple of 3. So I go down to, so I can say 8.27 times 10 squared times 10 to the minus 13. Times 10 to the minus 2 gives me 827 times 10 to the minus 15. And that's what they have there. And how they get these here. Okay. Femto 10 to the 15. 10 to the minus 15. So I have 827 times 10 to the minus 15. And it comes to be like this here. And 8.27 E 13 negative. So scientific notation looks like that. When you multiply this out. Next one is what? Microbytes. 10 minus 6. So I have 579 times 10 to the minus 6. And then end up with a minus 5.79 times 10 to the minus 4. And this is already, you can do this one too. There, you see the first one. Put that in engineering notation. Okay, and so you give it scientific notation. The number of watts is there. The number of bytes. Now this one here, okay, what they give us. This first one here is already in engineering notation. It's in gigawatts. And this one here, you put this one in scientific in engineering notation. So I have 1.11 times 10 to the minus 4. I can take that down to minus 6. So I can say 1.11 times 10 squared times 10 to the minus 4 times 10 to the minus 2. And that's going to make that 111 times 10 to the minus 6. And minus 6 corresponds to what? Micro. So minus 6 corresponds to micro. Okay. Here I have a minus 1 to put that in engineering notation. So I can say a 5.71 times that's 10 to the minus 1. Let's see here. And go down to a minus 3. Okay, so 5.71 times 10 squared times 10 to the minus 1 times 10 to the minus 2. And that makes this what, 571 times 10 to the minus 3 and minus 3 here is milli, which is milli. Okay. Some of these are already in engineering notation. This one is not. So you can multiply this out here and get it in decimal form. There. I'm going to put this in engineering form. 0.75 times 10 to the minus 1. Take it down to a minus 3. So I have 5.75 times 10 squared times 10 minus 1 times 10 to the minus 2 gives me 575 times 10 to the minus 3, which is milli in the table. this one here. So I can take this down. 546 times 10 to the 8th power. I can take that down to 6. So I can say 5.46 times 10 squared times 10 to the 8th times 10 to the minus 2. And this will make it 546 times 10 to the 6. And 10 to the 6 corresponds to mega, the table. Okay. And that's all I have for you.